In 2023, the world's oceans didn't just warm, they broke records in ways that stunned even veteran climate scientists. Marine heat waves swept across a staggering 96% of the global ocean surface, lasting longer, burning hotter, and spreading farther than anything ever recorded. In some regions, these heat waves endured for over 500 days, a relentless assault on marine ecosystems. Coral reefs bleached and withered, fish populations collapsed, and the intricate web of ocean life began to unravel. For millions of people, especially those in coastal communities, the impacts were not distant environmental concerns, but immediate threats to food security, livelihoods, and cultural traditions tied to the sea. The question that emerged from this unprecedented event was chilling. Were we witnessing an anomaly, or was this a glimpse into the planet's future climate reality? Marine heat waves, or MHWs, are defined as prolonged periods when ocean temperatures remain significantly above the seasonal average. Normally, they appear as short-lived spikes in temperature, often linked to temporary weather patterns. But in 2023, the story was different. The heat waves didn't just spike, they shattered every previous benchmark. The North Atlantic experienced a heat wave that began in mid-2022 and refused to end for 525 days straight, defying the natural cooling mechanisms of winds, evaporation, and currents. The Southwest Pacific saw an unprecedented expansion of warm water, stretching across more ocean surface than ever measured before. In the tropical Eastern Pacific, temperatures rose 1.63 degrees Celsius, above normal, amplified by the arrival of El Niño, a natural climate phenomenon known to temporarily warm global temperatures, but which, when layered over human-driven warming, became a dangerous accelerant. A global study led by Tianyun Dong and colleagues sought to understand the driving forces behind this extraordinary year. Using advanced satellite data from NASA's ECCO2 project, the researchers examined temperature patterns, wind speeds, cloud cover, and ocean currents. Their findings revealed that no single cause could explain what happened. Each region experienced its own unique combination of heat-inducing factors. In some areas, reduced cloud cover allowed more sunlight to penetrate the water, delivering direct thermal energy into the upper layers of the ocean. In others, weakened winds slowed the mixing of cooler, deep water with the surface, while diminished evaporation reduced natural cooling. Shifts in ocean currents trapped pockets of warm water in places where they would not normally linger. All of these factors were operating against the backdrop of long-term human-caused climate change, which has steadily warmed ocean basins for decades. The arrival of a strong El Niño in 2023 acted as the final push, magnifying the heat to record-breaking levels. The public reaction was explosive. When the story made headlines, some saw it as clear and urgent proof that climate change was accelerating faster than anticipated. Others countered with alternative explanations, pointing to overlooked natural factors. One frequently mentioned event was the Hunga Tonga volcanic eruption in early 2022, which injected an unprecedented amount of water vapor into the stratosphere, a potent greenhouse gas that could have contributed to temporary warming. Others speculated about the role of undersea volcanic activity, geothermal heat release, or natural multi-decadal oscillations in ocean circulation. Critics also accused the media of sensationalizing the findings, pointing out that while boiling oceans made for a gripping headline, the reality is that tropical oceans rarely exceed 30 degrees Celsius due to strong evaporative cooling feedbacks. But the peer-reviewed science is clear. While volcanic eruptions, geothermal vents, and natural variability can add heat locally or temporarily, they remain minuscule compared to the vast energy imbalance caused by human-emitted greenhouse gases. The oceans absorb around 90% of this excess heat, making them the planet's largest climate buffer, but also placing them under immense thermal stress. The record heat of 2023 was not simply the sum of short-term anomalies, it was the amplification of those anomalies by a long-term, human-driven trend. The ecological consequences of these heat waves are staggering. Warmer waters hold less oxygen, placing stress on marine life from microscopic plankton to massive whales. Coral reefs, already under siege from pollution and acidification, suffered mass bleaching on a scale rarely seen before. According to NOAA, between 2023 and 2025, over 80% of the world's reef areas are expected to experience bleaching-level heat stress. These reefs are more than colorful underwater landscapes. They are living fortresses that shield coastlines from storms, provide food and income to hundreds of millions of people, and harbor an estimated quarter of all marine species. When they die, the collapse radiates outward, threatening food supplies, tourism economies, and cultural heritage. Scientists warn that the patterns of 2023 might not be a one-off event. The frequency, intensity, and persistence of marine heat waves have been increasing over the past several decades. What we saw last year could be an early sign of a new normal in which prolonged extreme ocean heat becomes routine, or worse, a harbinger of a tipping point where the ocean atmosphere system shifts irreversibly into a hotter, less stable state. Such a shift could alter global weather patterns, disrupt fisheries permanently, and destabilize ecosystems on a planetary scale. The oceans are not literally boiling, but in the context of climate stability, they are simmering in a way that should command our attention. The events of 2023 were the loudest warning yet from the planet's life support system. Whether we choose to interpret them as an isolated freak year or as the start of a dangerous climate trajectory will determine how seriously we respond. What is certain is that the heat is real. The impacts are measurable, and the oceans, vast as they are, cannot absorb our excesses forever.